Welcome to my YouTube channel. So in the previous lecture, I have discussed about matrices and the determinants, and today I will discuss the remaining part of the chapter determinants. So first of all, minors and cofactors. Let A be n cross n, that is n square matrix. This you can write ij, n cross n, and mij is the n minus 1 square matrix obtained by deleting ith row and jth column. Then the determinant mij is called minor of the element aij of A. So generally, if A is 1 1 1 2 dot dot A 1 n, and this is last row n1 n2 dot 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 nn, and here this is aij element. So this is ai1j, and this is ai1 ai2 dot dot ain. This is jth column. So to find minor, we have to delete ith row and jth column. With the other elements, we get a, if this is n cross n, and we get from this by deleting ith row and jth column a n minus 1 cross n minus 1 matrix, which is square matrix. And if we find the determinant of this matrix mij, and we call it minors, and with the sign, if we define aij as minus 1 to the power I plus j into determinant I j, then is called, this is cofactor. So minor of an element aij is determinant of a square matrix whose order is less than 1 of the original matrix, and the determinant of this smaller matrix is called minor. And if we add with this sign, then we get the cofactors. Let us take an example. A is a given matrix. The elements are 1 2 3 4 5 6 7 8 9, that is 3 cross 3 matrix, and we will find the minor of the element 2 a23, that is second row third column. This is second row, this is third column, so this is 6. So we have to find minor corresponding to this element 6 and the cofactor corresponding to this. So to find m23, we have to delete second row third column. So second row third column, so we get this element are 1 2 7 8. And if you find this 8 minus 14 equal to minus 6, so minus 6 is the minors corresponding to this element. And if you find a23, this will be minus 1 to the power 2 plus 3 into this mij, that is m23, minus 1 to the power 5, that is minus, and this will be 1 2 7 8 will be minus of minus 6, that is 6. So this is the way how we find the minor of an element and also the cofactor. This is the minor we have used to find the determinant. So whenever we find the determinant for this matrix, we first 1 into the smaller matrix, that is this deleted, so 5 and 6 8 and 9. Similarly, minus 2 into, we deleted this, so 4 6 and 7 9. And lastly plus 3 into this deleted, so 4 5 7 8. So when we find the determinant for this matrix, this will be 1 into this, minus 2 into this, and plus 3 into this. So here this is the minors corresponding to this one element, and this is the minors corresponding to the element 2, and this is the minors corresponding to this element. Whenever we find determinant of a matrix, we use minors. So this is a 3 cross 3 matrix, and each minor is of order 2. So this is the concept of minors and cofactors. Now we'll discuss one algorithm how we find the determinants for a matrix whose order is more than 3. So generally, for n greater than 1, we can use this algorithm to find the determinant of a matrix, square matrix, whose order is n greater than 1. So always 2 cross 2 matrix is the simplest matrix from which we can find simply determinant. Multiply this diagonal minus multiply this. So always we will try to convert a bigger order matrix into a smaller order matrix. So to this we use this algorithm. So that's why this algorithm is named reduction of the order of a matrix. So we find the determinant for this four order matrix, and step by step we will use the algorithm. Our target is decrease one order from this current matrix. So this is a 4 by 4 matrix. So we will make this fourth order matrix into a third order matrix. So for this we use this algorithm. First we have to choose a element from this matrix which is equal to 1. If there is no 1, we will choose aij non-zero. That's we will first find a non-zero element. So from this matrix, this is first step. So we find 1. So there is 2 1. Let us take this 1 is chosen. So we choose aij, that is second to third column. So we choose a23 equal to 1. So second step, we have to make all the other elements 0 in this column. So for that we will use row operations, and we know when we apply this type of operation, k into ri plus rj implies rj, that is when we replace row rj by k ri plus rj, and this matrix, if this matrix become b, then the new matrix b and the old matrix a has the same determinant. So to convert this matrix into third order matrix, or to get 0 in this all position other than this 1, we will use this type of row operation. So first of all we make this element is 0. So for that we have to replace r1 by r1 minus 2 into r2. So under this operation we will get new matrix. So all other this will be same, 2 3 1 minus 2, and this row, this first row will be changed by this. So we get r1 minus 2 into this. So 5 minus 4 will be 1, 4 minus 6 will be minus 2, 2 minus 2 will be 0. So we make this 0. So 1 minus 1 is a plus 4. So this will be 5. And to make this 0, we apply another row operations, which is we replace r3. So new r3 dash becomes the r3 plus 3 into r2. So we did not multiply with r3 because we changing r3. So this was the operation. We replace rj by kri. So we can multiply the other with other row, but rj there is 1 into rj. So this is the rule. Then the matrix determinant of the new matrix will be same. So to make this 0, we apply this uh, operation. So new r3 become r3 plus 3 into this. So 6 minus 5 1. This will be 3 9 minus 7 2. This will be 3 minus 3 0, and this will be minus 6 9. So this will be 3. And to make this 0, that is minus 1 0, we have to change r4. So new r4 dash becomes, we apply r4 plus r2. So in this regard we are changing this element to 0 with respect to this. So we apply row operations between these rows and this row. So if we add this and this becomes 0. If we add this and this is 1. If we add this and this is 3, and if we add this and this we get 2. So this is a matrix 4 cross 4. But if we expand, so this was the first, and second one is the we have to apply row operations such that all other element other than this non-zero element 1 become 0. So we apply 3 operations. So there is a 4 row. So one row remaining same and other 3 have to be changed. So we apply 3 row operations. So we get this 4 order 4, and we have to expand this matrix with respect to jth column. So here we choose 2 3. So third column, with respect to third column we have to expand this matrix. So now, so you can note down. So from this, the determinant of this matrix will be same as the determinant of this matrix. So we delete this portion, and if we expand with respect to this element or this column, so all other 0 will be 0 into third order determinant will be 0, 0 into this 0 into, so this will be only the expansion with respect to 1. 1 is a 2 third, that is 2 3 element. So if we this is b, if this is b and the given matrix was a, so determinant of b is now with respect to this we get minus 1 to the power I into j, that is 2 third element, second row third column. So this will be 2 plus 3, and the determinant b is, so this will be the third order matrix, that is 1 minus 2 5 1 2 3 3, this 3 1 2. So the steps are, first we have to choose a non-zero element. If this is 1 then it is good, otherwise you choose any non-zero element. And second step, we have to apply row operations to convert all the elements in this jth column made to 0 other than this element. And third, we have to expand the matrix after the row operation we get corresponding to that jth column. And after this we get, this was minus 2, I think this will be minus 2. If I make a mistake, please check. So this will be minus 2, so this will be plus, this will be minus. So from this minus 13 25, so 38 minus into minus 38, that is 38. So after row operation we get a matrix from which we expand with respect to third column, and we get this result, and this will be minus 2. If I made a mistake, please check. And after that we get the answer 38. The previous matrix, given matrix A, determinant of the given matrix will be 38. So that's it. Now we will discuss the classical adjoint of a matrix. So the classical adjoint of a matrix A is the transpose of the matrix of cofactors. So let us given n cross n a given matrix. So from this, Aij is the cofactor of Aij, where A is given Aij. This is n cross n. So Aij's are the cofactors of this. So from, if we write B as the matrix of cofactors of A, so we get, this is capital A11, A12, A dot dot A1n, and similarly we get A n1 dot dot A_n. So these are all, A11 is the cofactor of the element A11. So similarly we get this. So this is the matrix of cofactors, and then adjoint. So classical adjoint of A can be written as this, denoted by this, will be the transpose of the matrix of cofactors. So if B is the cofactor matrix of the matrix A, then the adjoint will be B transpose. Let us find one adjoint for a matrix. Here A is given, so we will find adjoint of A. So first we find, this is A 11 12 13 dot 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 A 33. So first we find A11, that is cofactor with respect to this 2. So for this is 1 element, so this will be minus 1 to the power 1 plus 1 into this will, if we deleted this row and this column, so we get minus 4 2 minus 1 5. So we get, this is plus 1, so this will be minus 20 minus a plus 2, so minus 18. So similar process you can find, that is matrix of cofactors, that is B. We find this matrix again. So if we put this minus corresponding to, will be minus 20 plus 2 minus 18. corresponding to this 0 minus 2. This 0 minus the plus 4. 0 minus the plus 4. And corresponding to this 15 minus 4, 11. This 10, 10 plus 4, 40. This will be minus 2 minus 3, minus 5. And corresponding to this 6 minus 16, so minus 10. With this, so 2, 2 to 4, and this will be minus 8. This is the matrix of cofactor, matrix of minors corresponding to each element. So now we assign sign. So this will be plus, minus, so minus is plus, plus, minus, plus, minus, so this will be plus, plus, minus, plus, minus, plus. So the matrix will be minus 18, 2, 4, minus 11, 14, 5, minus 10, minus 4, minus 8. This is the matrix of cofactor, that is B. So if we take transpose, this becomes adjoint of A. So adjoint of A become minus 18, 2, 4, minus 11, 14, minus 11, 14, 5, minus 10, minus 4, minus 8. This is the way how we find adjoint. And if we find the determinant of this matrix, then we can find the A inverse, which is adjoint A divided by this matrix. For this matrix, we can find inverse. So this is the adjoint matrix, and if we find the determinant of this matrix, so we expand with respect to this as there is 1 0. So 2 into minus 4 2 minus 1 5 minus 0, this is plus 1. So 3 minus 4 minus 4 minus 4 2. So this will be 2 into minus 20 plus 2 plus 1. So 6 minus 16. So 2 into minus 18 minus 10. So minus 36 minus 10. So that is minus 46. Now this adjoint is this. So A inverse will be 1 by minus 46 into this adjoint. So this will be the inverse. So this is the way how we find inverse and adjoint. So for today, that's it. So if you like it, please subscribe my channel, and in the next lecture I will discuss how to solve the linear system of linear equations using this inverse of a matrix, that is matrix properties or Cramer's rules or Gauss elimination method, like that. So if you like it, please subscribe and share with your friends. So this will be very beneficial for the students of Technology Bhagalpur whose coursework, that is course is MA 101. So you guys will be very benefited by this lecture series. So thank you very much.